Now let us move on to the concept of LCM. LCM basically means the least common multiple. As the name suggests, among the multiples of a given set of numbers, the common multiple which has got the least value will give the value of the LCM that we are looking for. Okay, so if we have three numbers 36, 72 and 48, the first multiple that is common to these three numbers will be our LCM. Fine. So I have found out the LCM to be 144. Now I know that 144 is perfectly divisible by 36, 72 and 48 because 144 is one of the multiples of all the three numbers. Correct. Instead of 144, suppose we had a slightly higher number, let us say 149, which is actually 5 more than 144. What would happen when I am trying to divide 149 by either of these numbers? I will end up with a remainder of 5. Correct? If I am dividing, instead of 149, suppose I have got a number 150. If I am trying to divide 150 by either of these numbers, what would I get? I would get a remainder of 6. Okay. So what do we understand from this particular example? If you have got three numbers randomly, x, y and z, they are bound to have an LCM. Somewhere along the way, they will have an LCM. Okay. These three numbers can perfectly divide LCM. You can divide the LCM perfectly by x or y or by z because they belong, LCM is actually in all the multiples of x, y as well as z. Okay. Suppose I am increasing the LCM with a 5 and if I am trying to divide these numbers, what would happen? I would end up with a remainder of 5. Correct? So, if I need to find a number that will leave a remainder supposedly of 5 when I am dividing with x, y or z, what do I need to do? I need to find the LCM and increase it by 5. Because LCM is a number that is common to all the three numbers and is perfectly divisible by either of those numbers. But if you have to leave a remainder of 5 or 11 or 10, accordingly as in the question, we need to increase the LCM by that number. Clear? I have taken a set of three numbers 12, 15 and 24. Find the least number which is divisible by 12, 15 and 24. So you know that we need to find the LCM of 12, 15 and 24. So let us find the LCM. I am going to go for common division. You people, when you are writing for the board examination, please go for prime factorization. So, the product of this will give me the LCM. 4 into 3, 12, 12 5s are 60. 60 into 2, 120. So 120 is the LCM of these three numbers and that is the least number that is divisible by all the three numbers. Now, second part. Find the least number which when divided by 12, 15 or 24 leaves a remainder of 8 in each case. So when I am increasing 120 by 8, I will get 128 and if I am dividing 128 by either of these numbers, I will get a remainder of 8. So it is basically LCM plus the remainder. Okay. Find the greatest number of 6 digits exactly divisible by 24, 15 and 36. Okay, now we need to decide whether this is a sum on HCF or on LCM. So what are they asking here? They are asking for a number which is divisible by 24, 15 and 36. So if suppose the number is x, this should be possible, which means that the number has to be greater than either of these numbers. So we are not looking for HCF. We are looking for LCM. Okay. Once you have decided that, we need to see what is the difference between a normal LCM sum and this particular sum. In this particular sum, they are not asking you to find the number that is divisible by 24, 15 or least number that is divisible by 24, 15 and 36. They are asking you to find the greatest number of 6 digits or the greatest 6-digit number that is divisible by this. How do we go about this sum? You know that the first number that is divisible by 24, 15 and 36 is the LCM. Okay, suppose we are finding out the LCM of 24, 15 and 36 by prime factorization or by any other method. You should be getting the value as, you will get the value of the number as 360. That is the LCM of these three numbers. Now, this is the least number. So, along the multiples of 24, 15 and 36, there is a 6-digit number which is divisible by all these three numbers, and somewhere along the way over here, we have this 360. Okay, so what do we understand from this? It basically means that any number that is common to all these three numbers will be some multiple of the LCM. So that particular 6-digit number has to be properly divisible not only by these three numbers individually but also by their LCM. Now our task is to find the greatest 6-digit number that is divisible by 360. So here I have written down the greatest 6-digit number, which is 999. Okay. Now let us see whether this is divisible by 360. So beyond that, it's a 7-digit number, so we are not bothered about it. So let us see what we are getting when we are dividing this by 360. Okay. I have done long division over here. You can see that this particular number is not divisible by 360. We are getting 279 as a remainder. So we know that if this 279 was not there in this particular number, it would have been properly divisible. So I will subtract 279 from this particular number in order to get the highest 6-digit number that is divisible by 360. Clear? Let's do one more similar sum. Find the greatest number of 4 digits exactly divisible by 12, 15 and 8. Now there is a number that is divisible by 12, 15 and 8. The least number is our LCM. Without finding the least number, it is going to be a very difficult task finding the greatest number of 4 digits. Now you know that any other number that is divisible by all these 3 digits has to be a multiple of LCM. So here we are getting the value of the LCM as 120. Now I know that it's the next number or the number of greatest number of 4 digits which I need to find has to be a multiple of 120, which means that that number should be divisible by 120 as well. Now what is the greatest number of 4 digits? It is, this number has to be divided by 120. If it is not divisible by 120, I need to find what is the remainder. Okay. So I have divided 9999, which is our greatest 4-digit number, by 120. You can see that I am getting 39 as a remainder. So if that 39 was not there in the number, I would have gotten my answer. So I am going to subtract 39 from 9999. So I will be getting my answer as 9960. That is the greatest number of 4 digits that is exactly divisible by 12, 15 as well as 8. So I hope you have understood the basic concept behind these kind of sums. So let us say that we have got a set of 3 numbers. It can be 2 numbers, 4 numbers, any number of numbers. But now for example, let us say 3 numbers are given to you. We know that each number will have infinite multiples. Okay. Along those multiples, so this is multiple 1, multiple 2, multiple 3 and so on, multiple 4. So this is going on like this. Each number has multiples. Somewhere along the way, these 3 numbers will have a common multiple. The first such kind of multiple which is common to all the 3 numbers we call as LCM or the least common multiple. We know that already. Now along the way, so the multiples are going on and on. So somewhere further along the way, you will find another number that is common to all the 3 numbers. That is our second common multiple. That second common multiple will be able to divide LCM properly, or basically this second common multiple will be a multiple of LCM also. See, LCM was already divisible by these 3 numbers, correct? So the second common multiple has to be divisible by these 3 numbers, basically means by LCM. Fine. I hope you people are clear with this particular concept. So let us do one more sum before we move on to the next type. Find the smallest number which when increased by 17 is exactly divisible by both 520 and 468. Now let us see how we can approach this particular problem. Now find the smallest number divisible by 520 and 468. What would you have found? You have found the LCM, correct? Now I have a number which when increased by 17 is divisible by 520 and 468. So what is the smallest number which is divisible by 520 and 468? It is a LCM. So the LCM of 520 and 468 is the least number which is divisible by both these numbers. Let us first find the value for that. You will get the value of the LCM as 4680. Now this particular value of LCM is equal to the number plus 17. Instead of directly asking what is the smallest value that is divisible by these two numbers, they are telling that there is a number when I am increasing by 17 is the smallest number that is divisible by these two. Okay. So x plus 17 is equal to 4680, where x is the number that has to be increased by 17. So what is the value of the number equal to? 4680 minus 17. So what do you get? Okay, 4663. Okay, I hope once you understand the concept very clearly, you will know how to apply this concept to this application sums. So in certain cases, they will ask you to find the greatest 6-digit number or the least 3-digit number, however it is, or they will ask you something like this, the number when increased by 17 or decreased by a value. So in all those cases, you need to understand that two things. One is that LCM is the least number that is divisible by the numbers. Any other common number that is divisible by the given set of numbers has to be a multiple of LCM. Common logic. Now, the third thing is that whether you are increasing the number or you are decreasing the number, the smallest number that is divisible is always the LCM. Find the smallest number which when divided by 35, 56, 91 leaves a remainder of 7 in each case. So, we need to find a number in such a way that when it is divided by these three numbers, it is leaving a remainder. So, when it has to leave a remainder, you know that that number has to be slightly greater than the number by which these three are divisible. Okay. What is the smallest number divisible by these three numbers? It is our LCM. If my LCM was slightly increased by 7, what would happen when I am dividing by these three numbers? It would leave a remainder of 7. If I am increasing by 5, what would happen? It would leave a remainder of 5. So, we need to find the LCM of these three numbers and increase it by 7. Okay, so just have a look at the way in which the answer is presented. 7 plus the LCM of 35, 56 and 91 is the required number. Now to find the LCM of this, I have done it by prime factorization. When you are writing for your examination, please go for prime factorization. Okay, so I have written the steps. So the LCM is 3640 and therefore my required number is 3647. So you know that each step carries mark, and so write accordingly in such a way that you do not skip any steps and that you get the complete mark once you have arrived with the answer. If 3 is the least prime factor of A and 7 is the least prime factor of B, find the least prime factor of A plus B. Now, this is a sum that I have taken from R.D. Sharma. Like most of the sums that we did here today, we have taken from R.D. Sharma only. So now let us apply basic logic in whatever we have done in order to solve this particular sum. If 3 is the least prime factor of A means you know that a prime factor lesser than 3 is only 2, which is the only even prime factor. Okay, so 2 is out of question. So if 3 is the least prime factor of A, we know that that particular number has to be an odd number because the only even prime was 2 and it is out of question. So the first one is an odd number. Similarly, the second one, since 7 is the least prime factor, this is also an odd number. Okay, now find the least prime factor of A plus B. When I am adding two odd numbers, what do I get? Let it be of any power. Okay, so let it be of a raised to n, where n is of any power. This is also of any power. Whenever I am adding two odd numbers, I will always get an even number. In the case of an even number, what is the least prime factor? It has to be 2. So, the least prime factor of a plus b is 2. Okay, see, 3 is the least prime factor of a, means a has to be an odd number. Similarly, b has to be an odd number. Now, I am taking in such a way that it is a raised to 1. It could be a into a to how much ever number of times a is multiplied. Still, that would be an odd number. In the case of b also, multiplying odd numbers will always give me an odd number. So, b is also an odd number. When I am adding or subtracting two odd numbers, I will get an even number. In the case of an even number, the least prime factor is a 2. If p and q are co-prime, will p square plus q square be co-prime? What are co-prime numbers? Co-prime numbers are those numbers that do not share a common factor. So, their only common factor between them is a 1. Their factors do not have anything in common. So, p has got a certain set of factors, q has got a certain set of factors. Nothing is common in between them. In the case of p square, what is really happening? P into p, which means this has got the same factors, but again written one more time. In the case of q, or in the case of q square, what you are getting is the factors of q just written one more time. So again, p square and q square will not have any common factors, so they will always be co-prime. The product of two numbers is 2028. The HCF is 13. The number of pairs of such numbers is. So we know that when the HCF is given to you, you can represent the numbers in terms of HCF and two numbers which are co-primes. So that would be 13 into x and 13 into y, because 13 is the HCF, x and y are co-primes. Now it is given that the product of the two numbers is 2028. So 13x into 13y is 2028. So from this I can find out the values of value of x into y. 2028 divided by 13 into 13. Okay, I am getting the answer as 12. So in order to find co-primes that satisfy this particular value, I have got two sets, 1 and 12 and 3 and 4. The reason being x and y are co-prime. So I need to find two co-prime numbers. Otherwise I could have taken 6 and 2 also. But in this case I cannot take because I am looking for co-primes. So there are two pairs of numbers.